So that's our question. Most of these questions will come as long as this one or even longer than this one, but they are very interesting even to work out. So we are told that 70 grams of a solid initially at 25 degrees Celsius was carefully dropped into water in a calorimeter at 16 degrees Celsius. If the final constant temperature of the water and the solid was 54 degrees Celsius and the mass of water is 500 grams, determine the specific heat capacity of the solid. In this question, we are told to assume that the heat absorbed by the calorimeter is negligible. So we are not going to consider the heat gained by the calorimeter because we are told to assume that it is negligible. Then we are told take specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. Now, whenever you are given such a question, the first thing that you need to ask yourself is, what is losing heat in this question and what is gaining that heat which has been lost by the other substance? So like in this question, we are having a solid initially at 25 degrees Celsius, which is being dropped into water in a calorimeter at 60 degrees Celsius. And then we are told that the final constant temperature of water and the solid was 55 degrees Celsius. So what is losing heat and what is gaining? We can see clearly that the water is initially at 60 degrees Celsius, but now when this solid is dropped, it goes down to 54 degrees Celsius. So here water is losing heat, and that heat lost by the water is being gained by the solid. So we'll start by saying that heat lost by water is equal to heat gained by the solid. So that is very key. Heat lost by water is equal to heat gained by the solid. Then after that, we can analyze and see what we are given so that now we can calculate. But before that, we can write first the formulas here. So heat lost by water, we know it will be given by the mass of water times the specific heat capacity of water times the change in temperature, which is equal to heat gained by the solid, mass of the solid, times the specific heat capacity of the solid, times the change in temperature. So in our question, we are told that the solid has a mass of, so the mass of the solid we have, which is 70 grams. We can change it into the SI unit, which is kilograms. So we'll have 70 all over 1,000 kilograms. Then the solid has an initial temperature of 25 degrees Celsius. So the initial temperature of the solid, we can write it that way, is equal to 25 degrees Celsius. It is dropped into water in a calorimeter at 60 degrees Celsius. So the initial temperature of water is 60 degrees Celsius. The final constant temperature is 54 degrees Celsius. And the mass of water we are given as 500 grams, which is 500 all over 1,000 kilograms. And we have also been given the specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. So we want to calculate the specific heat capacity of the solid. So that is the question. So when we have all this, then we can be able to calculate here. But before we get to that, we need to get the change in temperature for the water. Change in temperature, the temperature change for water. In our case, we have the initial temperature of the water, which is 60. The final is 54. And therefore, the change will be 60 minus 54, which is 6. Then we also need to get the change in temperature for our solid. Initially, the solid is at 25 degrees Celsius and the final temperature is 54. So we have 54 minus 25. So what do we end up getting? We end up getting 29. That is our change in temperature for the solid. So that's what we have. So we now want to apply this formula. So we are saying that mass of water times specific heat capacity of water times change in temperature is equal to mass of the solid times the specific heat capacity of the solid times the change in temperature. So we substitute what we have been given. So what is the mass of water? From there, we have 500 all over 1,000. Specific heat capacity of water is 4,200. Change in temperature for water is 6. Is equal to mass of the solid, which is 70 all over 1,000. Specific heat capacity of the solid is what is in question. And the change in temperature for the solid is 29. So that is what we have. So you just use your calculator and find what you have. So we have 500 divided by 1,000 multiplied by 4,200 multiplied by 6. So you get 12,600. So on this side you get 1,200, 600 is equal to, on the other side we are multiplying 70 divided by 1,000. We are multiplying by 29. So we get 2.03. 2.03 multiplied by the specific heat capacity of the solid. So we end up getting 12,600 is equal to 2.03 multiplied by the specific heat capacity of the solid. And therefore, to get the specific heat capacity of the solid, we divide both sides by 2.03 divided by 2.03. So we have that cancelling. So we have the specific heat capacity of the solid to be 12,600 divided by 2.03, which you end up getting as 6,000. So you end up specific heat capacity of the solid will be 6,206. We can write to 2 decimal places, so it will be 0.90. And therefore, that is 6206.896552, which we round off to be that. So our specific heat capacity of the solid is 6,206.90 joules per kilogram per Kelvin. And that is the specific heat capacity of the solid. Hoping that it's clear. So you need to note that here water is losing heat and it is losing heat to the solid. So we are saying heat lost by water will be gained by the solid. So when that solid at 25 degrees Celsius is dropped into the water at 60 degrees Celsius, the final temperature becomes 54 degrees Celsius. So heat lost by water is equal to heat gained by the solid. And as we said, the formula for heat lost, or the formula for calculation of heat energy, mass times specific heat capacity times change in temperature. Here it is the change in temperature for water, and here is the change in temperature for the solid. The solid changes from, the temperature of the solid changes from 25 to 54, for water from 60 to 54. So you find what you have been given to get what is in question, and you get it to be that.